Hi, I'm Sofia. Hi, I'm Natalia.
My name is Mariano.
And I'm Santiago.
We're gonna tell you about exercise number 2. Okay, so here we have problem part A. We have to calculate the area of the region bounded by the function f, which is x squared minus 1. X equals to minus 3 and x equals to 2 and the x-axis. What does this mean? We have this function which is a parabola with one unit down, and we have the limits which are minus 3, 1, and the x-axis. This means we have to find this, and this area, which are 3 areas. So what do we do next? We use the limits to find, to plug them into the integral and then find the area. The limits of the first area are minus 3 and then minus 1, because that's just the area that the function goes through. So here we have it. We integrate, then we plug in the values, and we get 20 over 3 units. For the second area, as you can see, it's below the x-axis. This means that we're going to have a negative value. So we do the exact same thing, but with the new limits, which are minus 1 and 1. When you plug them in, you get minus 4/3. But then I'm going to go back to that. And for the third area, we have now the limits 1 and 2. So we do the same thing, we integrate, then we plug the values, and we get again 4/3, but this time it is positive. So what do we do to find the total area? Because we're talking about area, we just want to add them all up, so it doesn't matter if this is negative, we just get the absolute value, add them all up, and as a result you get 28/3 or 9.33.
Now it's problem B, which asks us to calculate the volume of the solid if the region bounded by the function f, the vertical lines x equals 1, x equals 2, and the x-axis is revolved about the vertical line y equals to minus 4. The x function is x squared minus 1. First, we have to graph the function, which is this one, and the area that he asks us is from 1 to x1 to x2. And this is the area that we want to get, and it's rotated on y minus 4. To get the volume of this, we're going to use the washer method, which first asks us to find the big radius and the small radius. The big radius is 4 plus x squared minus 1, and the small radius is just 4. And the function goes like, and to get the volume, we do p times a big radius square minus a small radius square, and we integrate that. So first we put the both radius, and then we simplify. We finish getting x squared, x to the 4th power plus 6x squared minus 7, which the integral of that is x to the 5th over 5 plus 2x to the cube minus 7x, which gives us 42 over 5 plus 24 over 5, which gives us the end result of p 66 over 5, which is the same as 13.2 over pi, and that's the volume of the figure we want to get.
Part C asks us to calculate the volume of the solid if the region bounded by the function f, which is the parabola, the vertical lines x equal to 1 and x equal to 2, and the x-axis has semicircles in cross-sections perpendicular to the x-axis. This means that our rectangle is going to be vertical. So if we're talking about a semicircle, we have to put pi over 8. Integral from 1 to 2, because those are the limits of the region, of the function x squared minus 1 raised to the square dx. We raise this to the square and we get x to the 4 minus 2 x squared plus 1 dx. Then we integrate this and get x to the 5 over 5 minus 2x to the cube over 3 plus x, evaluated from 1 to 2. So when we evaluate this, we get this. we add all of the fractions together and get 46 over 5 minus 18 over 5. Then again, we subtract these fractions and we get as a final result pi over 8 of 38 over 15. So we multiply 8 times 15 and get 38 pi over 120. And if we simplify this, it gives us 19 pi over 60 units, which is the final answer.
So in problem number D, it says, if integral of 1 to b function of x plus 1 dx is equal to integral b to 6 function of x plus 1 dx, calculate the value of b approximated to 2 decimals. So what we're doing here is we are equalizing the equations, integrals. So what we did here, f of x, here we have it, so we just write it over here, and this is how the integral goes. X squared minus 1 plus 1 is equal to x squared minus 1 plus 1. Then we solve what's in here and we get x squared dx integral. We integrate them and we get x to the cube over 3 equal to x to the cube over 3. All those integrated by 1 to b and b to 6. So here we have to solve the integral. We substitute these and these ones, the numbers we have, and we got b to the cube over 3 minus 1/3 is equal to 216 over 3 minus b to the cube 1/3 over 3. Then we try to put all the b's in one side and all the numbers in the other, and so we have it over here, all the b's to one side and the other, and then we put them together. We solve this, we get 2b to the cube over 3 minus 217 over 3. We multiply this by 3 to eliminate the denominator. So at the end we have 2 times b to the cube equals to 217. Then we isolate b, put the 2 to divide, and we have 117 over 2. Then we divide this, we get the answer, and to isolate b, we pass the cube as a root, and we have 808.5, and we get the cube root, and we got b is approximated to 4.7695.